Hi guys, this is Ashank David, and in today's video we are going to talk about NumPy, which is a very important library for data science. So let's get started. Before I start this video, I would like to request you people to please like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. So without any further ado, let's get right into the topic. So when we talk about NumPy, what is this NumPy? Here you can see it's NumPy. It is very important for data science. Actually, NumPy is used for one major thing, and that is data analysis. We use it for data analysis. So let us understand about how this works. So when we talk about NumPy, NumPy is a linear algebra library for Python. The reason it is so important for data science with Python is that almost all the libraries in PyData ecosystem relies on NumPy as one of their main building blocks. So as you can see, NumPy acts as a main building blocks. It can be used for so many things. One of the things that NumPy is used for data analysis, which is a very important step in data science. In data analysis, we will do a lot of things. We will do data generation, we will be doing data cleaning, and there are so many steps involved into this. You will get to know as we progress into our course, and very soon you'll get to know about it. So data analysis is one of the thing, and because it can be done so well in Python because of NumPy library, it is one of the major building blocks in data science, as you can see. So now next, NumPy is also incredibly fast as it has binding to C libraries. Working with NumPy is very easy and it gives you a lot of things in few steps. For example, here I'll just take a small example. Creating arrays with NumPy are very easy because here we just have it as a function into NumPy. So very soon you're going to see that also when I'm going to show you Jupyter Notebook. Very easy to use, very simple. You just need to remember the functions that we use from NumPy, and it is going to be a lot more easier for you to understand how we are going to work with NumPy. Very easy. Okay. And it is very fast. So we'll see how. Okay, next. If you have Anaconda, install NumPy by going to your terminal or command prompt and typing this. Okay, so here if you have already installed Anaconda, we have already done this in previous two videos. If you have not watched those videos, I'll give the link in the description below for a Python data science playlist as well as Anaconda distribution installation with Jupyter Notebook overview. Last video we have done Jupyter Notebook overview as well. So go ahead and watch that. I'll give the link in the description below as well as in the I button. So please go ahead and watch that also. Then next, you can open up your command prompt and you can type conda install numpy if you're working with Anaconda command prompt, or you can directly go to your terminal and you can say pip install numpy. So it's very easy to install. Directly say pip install numpy and there you go. It will have your numpy installed in a few seconds. So this is how you can install NumPy easily into your system. All right. So next, NumPy arrays. So NumPy arrays are the main way we will use NumPy throughout the course. It's a very important thing. Majorly in this particular section of the course, we are going to mostly talk about NumPy arrays. And through NumPy arrays, we will do a lot of things. So let's go ahead and see what are NumPy arrays. NumPy arrays essentially come into two flavors, that is vectors and matrices. So what are vectors? When we talk about vectors, vectors are strictly 1D arrays. Okay, you already know what is 1D array, and matrices are 2D arrays, strictly 2D arrays. So when we talk about 2D matrices, you should know that matrices can still have only one row or one column also. So not only it looks like 1D, but actually the things are 2D arrays. We are going to talk about how that is going to look like. Basically, to create an array, we are going to use Python lists. If you have done Python lists before, if you have not done Python lists before, I would recommend you to do Python lists before. We have a dedicated video on that. I'll be giving you the link for that video in the uh, description also, and I'll put that into I button as well. So if a Python list you're not aware of, we use Python lists to contain multiple different types of elements, and this is lists can be used to implement NumPy arrays also. Okay, so NumPy arrays can be implemented using Python lists. So say suppose we have 1, 2, 3, 4, 5, some numbers into this, we will use NumPy on this, and NumPy will generate a array of this particular list. So how we will do that, how we will work with that, I'm gonna tell you in depth very soon. You'll get to know as soon as I switch to Jupyter Notebook. So this is how, guys, NumPy arrays will be used, and this is a brief introduction to NumPy that I have given you right now. Now let us move on towards our Jupyter Notebook and we'll see how NumPy can be used. So there you go, guys. I have created my Jupyter Notebook, and in this case, this is my Jupyter Notebook. Let me just rename this Jupyter Notebook as NumPy, and we'll move on with this. Okay, I'm gonna save this workbook once. I have already given you the overview of how Jupyter Notebook looks like and what are the commands and shortcuts that we will be using throughout our course in the previous video. So if you haven't watched that video yet, uh, I'll recommend you guys to go ahead and watch that video first and then come to this video if you want to learn about Jupyter Notebook. So without any further ado, let's get right into the NumPy arrays. So here we are talking about NumPy arrays, guys. So let me just write a basic NumPy arrays. Let me just zoom in for you guys a little bit. Okay. And here I want to make this as a markdown code. So I can just make it like this and I can just execute it, and there you go. It'll create a nice NumPy array heading for us. So this is what you call as markdown code. Okay. Now let us start working with NumPy arrays without any further ado, guys. So just now I have told you that NumPy arrays can be created by using Python lists. So first let me create a list. I created my list and I said equals to, I created a list as 1, 2, 3. Okay, so I created this list and let me just execute this one. So if I execute it, I will just say shift plus enter, or you can use this run button in order to run this. I am using shift plus enter in this case, and I said my list equals to. So I created a list in Python. To print that list, I can just take the name of that list and I can execute this and it just should print my list like this. So this is your my list, guys. So this is a basic list. Using Python, we created this list. And now I will tell you how to use NumPy to make this as a NumPy array. So to do that, first we have to import NumPy into our Jupyter Notebook. And to do that, you have to first install NumPy. And in the brief introduction, I have told you how to install NumPy. You have to go to CMD and you have to say pip install NumPy or conda install NumPy if you're using conda environment. So there you go. Once you have installed NumPy successfully, you can here come back to your Jupyter Notebook and say import NumPy as NP. So what is this we are importing NumPy as NP means this is our alias name. Through this we can access all the major function coming out from NumPy. Instead of using NumPy dot, we will use NP dot. So this is going to work just as an alias name into it. We are going to execute this. So now our Jupyter Notebook knows that we have imported our NumPy and we are using it as NP. So I can say now NP dot, to create an array, I can say array. Array is a function here which comes from NumPy, and I can pass this my list, right? So I can pass this list right here. So now if I run this code, you can see an array has been created. This is a NumPy array. This is how a NumPy array looks like. And in the discussion, I have told you, right, that this is a 1D array. So it become a vector. So this is a 1D array or a vector in this case when you talk about in data science. This is how a vector looks like. So if I talk about this, I can do it like this. Let me just first save it into our variable. So ARR, and then I will just say ARR in the next line, and I'm gonna say it like this. And here I'm gonna write a comment that this is a 1D array, basically vector in this case. Okay. So this is a 1D array, and this is how a 1D array looks like. I hope you understood this. Okay. Now let's create a matrix. So let me create a matrix. To create a matrix, we need to first create, I'm gonna say my underscore mat for matrix, and I'm gonna say equals to. Now if you want to create a 2D array, 2D NumPy array, you will create list of lists. So I've created one list using single square brackets. I'm gonna create more single. more, square brackets under this like this, and I'll separate them with a comma. So this is going to be a list of lists where first list contain 1 comma 2 comma 3. I'm gonna say next list contains 4 comma 5 comma 6. Next list contains 7 comma 8 comma 9, and so on. So this is one whole list of three different lists inside it. So list of lists. So this is how you create 2D array. In this case, I said like this. Let me just declare it like this, and then I'm gonna say np dot array. I'm gonna call this array function from my NumPy, and I'm gonna say my mat. That is, I am passing this whole list of lists inside this function, and this should create a 2D array like this. You can see this is how NumPy array created 2D array. This is how it looks like, guys. So this is what you call as matrix. How you got to know? Not only because of how it is printed, but if you want to check, if you want to confirm it is a 2D matrix, it is going to look like this. Always it will have starting with two square brackets and ending with two square brackets. If you see starting and ending with two square brackets, that means it is a 2D array or matrix in this case. So let me also like this is how it looks like. Okay, so now I will just write it's a 2D array or it's a matrix. I hope this is very clear, guys. So what we have done till now, it is very clear. Okay, so this is how you can work and basic operations related to how you can create arrays. So we created our list, then we imported our NumPy as NP, and then we used our array function and we passed our list which we created, and it created our vector for us. Okay, this is your data generation. Right now we are doing data generation with NumPy. Okay, so in this case, I am saying matrix, and I passed lists of lists, and then I passed it into the array function, and it provided me 2D array or matrix in this case. This is what you call as 2D NumPy array or matrix in this case. Okay. Now, next, after doing this, let me show you some of the more very popular NumPy functions which are available to us. NP arrange. So what is this arrange function? So I'm gonna say markdown, and I'm gonna say NP arrange. And before this, I'm gonna say this, not arrange 2. I'm gonna say just arrange. Okay. And after this, I can just write here np dot arrange, np for numpy dot arrange, I will say, and I'm gonna say it's a function, right? So I'm gonna pass two parameters here. So 0 comma 10 I passed. If I pass 0 comma 10, it is going to arrange the numbers. It is going to create an array using NumPy library, which is going to return us a vector of numbers from 0 to 9, because it is very similar to working with a range function in Python, guys. This is the lower limit, this is the upper limit. It starts from 0, but it never goes to 10, it goes to n minus 1. So this is going to create a vector for us which is going to have numbers from 0 to 9. So if I say shift plus enter, which is going to run this code, you can see it created a array of single dimensional array or vector in this case from numbers 0 to 9. It is very similar to working with a range function in Python, guys. If you have worked with a range function in for loop in Python, it is very easy and understand to learn. This is mostly used. Okay, this is most used function most of the time in NumPy arrays. Okay, so whenever we don't directly say array all the time, but this is the most common one which we use, well, that is np.arrange. The quickest way of creating an array by just directly saying through the NumPy, that is np.arrange, and this is going to create a array of whatever. Okay. And just now I told you it works just like a range function, right? So if this is a range function, then it would have the third parameter also. So I can say np dot arrange, and I can say 0 comma 10. This is upper limit, lower limit, comma I said 2. So now this is lower limit, upper limit, and this becomes steps, just like how we have range function. So now you can see if I run this code, it will print 0, 2, 4, 6, 8. So basically it is printing alternating numbers into this array. So it created a vector and it is skipping two elements into this. So the third argument in this case will act as a step. as how you work with range function. Okay, I hope you understood this very well. So now this was the very first function that I told you about, and which was arrange function. Now let me create one more function, and I'm going to show you how we work with this, and that is np zeros. Okay. So what is this NP zeros? NP zeros is another popular, very popular function which we use to create a vector or a matrix of zeros. So for example, I can write here NP dot zeros, and because it is a function, I will pass some parameter into this function, right? I can say 3, and it will produce a vector of 3 zeros. So let me just run it and show you. It produced a vector in the sense 1D array, guys, again of zeros. So this is a very popular one to create array of zeros only. So we can just say directly np dot zeros, and we passed one single argument into this, and it created a single dimensional array, or in this case vector of only zeros, and this number is telling us how many zeros we want into our vector. I hope this is very much clear. Now with this you can also create matrix. So if I say np dot zeros, and in this case if I pass, let's say I can pass a tuple of 2 comma 3. Tuple you guys already know, right? Tuple, we can't edit tuple as here. Lists are like this. We use square brackets in order to tell about lists, but when we use round brackets, it's a tuple. So inside a tuple, you will give a fixed dimension. Okay. So now I want a zeros array of zeros, a multi-dimensional array of zeros with dimension 2 by 3. So if I run this code, you can see 2 rows and 3 columns. I hope this is very much clear. And it's a two-dimensional array. How to identify it's a two-dimensional array? By seeing this two square brackets. I hope this is clear. Let us change this to 5 comma 5 and press enter, and press your run button or shift plus enter. You can see that it created a vector, or not vector, it created a matrix of zeros of dimension 5 into 5. So 5 by 5. So this is how you can use NP zeros, guys. Next, very popular function, just like how we had zeros, now we have functions for ones also. So let me create that function for ones also. So I can say NP ones, and here I will just say this. Okay, so if I want to do like how we were doing with zeros, we will create array of ones. Okay, so I will say np dot ones, and I can pass a single argument also. I said 3 or 4, whatever. If I print this, you can see it says array of 1 1 1 1. So just like how zeros were working, very similar, it is working with ones also. So if you want an array of ones, you can use np dot ones. If you want to again uh, create a matrix of ones, you can say np dot ones. And just like how we passed the dimensions for zeros, similar to that also you can pass dimensions for ones also. So let's say I created 2 comma 3, and if I run this, you can see it created a array of two-dimensional array, or matrix in this case, of ones only. This is our dimension, guys. Again, I told you, if I say 5 comma 5, I can run this, and you can see that it gave us the array of ones only. This is the matrix of 5 by 5. I hope this is very much clear. So this is NumPy ones, guys. Okay. Now next is a very popular one. I am gonna create a markdown for it. NP, we have linspace, linspaces, NP linspaces. Okay. So what is this NP linspaces? So let us see. NP linspaces are used to make, I can say, to make arrays with proper point difference. Okay, so let me show you what I'm talking about. So I'll say np dot linspace. It's not linspaces, it's linspace. And then here I'm gonna pass 0, comma, let's say it'll go till 5, comma, I want 100 differences. Okay, what is this? So just like how we had a for loop, we had a range function in this, right? A range function in NumPy. It was using steps, right? So when I said 2, it used to skip 2 numbers, right? But in this case, in linspaces, this is not steps. Remember this. This is not steps. This is points. So these many different points will come. So let me first print it. So I executed this and you can see that so many numbers came here. What is this numbers? What are these numbers? So let me just show you first. It is a single dimensional array only. You might think that it's a multi-dimensional array. No, it is not a multi-dimensional array. You can see it's only one square bracket is there. Okay. So this is a single dimensional array only. But in this case, all the numbers from 0 to 5 are printed, but with the space of 100 numbers. You can see there is 100 numbers gap between each and every number between 0 and 5. So small decimal points also will be covered. Let's say I want thousand number difference, point thousand numbers difference. Okay. If I run this, you can see so many numbers came and it gave me the difference of point thousand numbers between 1 and 5. So many numbers can be possibly right in between zeros and, 5, between 0 and 5. So let's make it more simpler. I'll say just only I want 10 difference. So you can see it gave us the value from 0 to 5, but with 0.10 difference values between all the numbers between 1 to 5. I hope this is very much clear, guys. Now that is the difference here. I'm gonna just say 100 and I'm gonna execute, and now this is gonna show you a standard output how it is going to look like. This is what linspaces does. Basically, it gives you a proper difference between the points between two values from lower limit to upper limit. So this is what linspaces does in your NumPy library. Okay, I hope this is very much clear, guys. Next, let's say you want to create a identity matrix. What is an identity matrix, guys? A matrix which has all the elements as 0 except for its diagonal. Diagonal values will be, 1. So let us see what it is. So see, I'm gonna quickly create a markdown, and here I'm gonna say NP I. I is used for identity matrix. Okay. So I'm gonna just make it as a heading. If you guys are wondering how I'm doing it without going to here and selecting markdown, I'm going to tell you, see if I'm in the code mode, right? I'm in a writing mode right now. If it is green and if your cursor is blinking, it is on editing mode. Just press escape once and you have came out of your editing mode and it has become blue, right? Now just only press M and this is going to convert this into markdown. So this is the keyboard shortcut of creating markdowns, guys. Because I'm used to it, I'm able to do it very quickly. If you want to delete some cell, you can just come out of it and then press D double time and it is going to do it. Now I'm just gonna say shift plus enter, and right now I'm in the cell mode. I'm gonna quickly press escape and then M. It is going to go into markdown mode, and here I'm gonna jot down something. So let's say I created to create identity matrix. Okay, and I press shift plus enter and it gave us only the sentence. But when I say hashtag and then space, it will give us a heading, markdown heading. Okay, next, to create an identity matrix, I'm gonna say np.eyei and I'm gonna pass some argument in this. So it will give me a numpy identity matrix of 4 rows, okay, and 4 columns, and I'm gonna just print it like this. I'm gonna say shift plus enter and it created a matrix. It's a 2D matrix, guys. How we got to know? By this double brackets, okay. And then here you can see it's an identity matrix. All the diagonal elements are 1 except for diagonal elements everything is 0. I hope this is very much clear, guys, to you guys, all of you guys. So this is the identity matrix. This is how we work with identity matrix from NumPy. I hope this is very much clear, guys. Next, we are going to learn about a very important function in NumPy, and that is a random. So I'm gonna just make it as a markdown, and I'm gonna say np random. And here, before I go ahead, I can just say something like, you know, this. And here I'm gonna create some random numbers. If I want to generate some random numbers, I'm gonna just say to create random numbers arrays. Okay, how do we do that? Let's say I'm gonna say np dot random And np.random is one library. Through that, we can access more functions into random library. Random is also one of the libraries, and inside that random library, we have functions called as, let's say, rand. Rand is one function which is coming from random library, which is going to use to create some random array of some random numbers. Okay, in this case, when I say rand, I can pass one value into this. Let's say I passed 5, and this is going to give us a numbers, an array. I'm going to first show you the output. In this case, if I run this, you can see I got an array of numbers from 0, like 0 to 1. Between 0 to 1, it generated me some random uniform distribution. So basically, what this rand does is it gives you numbers as uniform distribution from 0 to 1. So in probability, you might have learned about uniform distribution. So uniform distribution happens to be from 0 to 1. So it gave me some random numbers of uniformly distributed random numbers from 0 to 1. And it gave me this. So number of times you'll run this code, every time the numbers will get changed. I hope this is very much clear, guys, because we are generating random numbers here, right? So you can see that every time I'm running this, it is giving me some different numbers. I hope this is very much clear, guys. So basically, it is giving us random numbers array, but it is giving us a uniform distribution between 0 to 1. In this case, whatever the uniform distributed numbers are from 0 to 1, that will be printed. Its array is going to be printed of random numbers uniformly distributed from 0 to 1. I hope this is very much clear. When we use rand, we get the uniform distribution from 0 to 1 of random numbers between 0 to 1 in a form of an array. Okay, guys, this is how you do it. Now, if was an example of, vector or single dimensional array or 1D array, in the next case, you can do something like this also. You can say random dot rand, and inside this you can give the two numbers. So I said 5 comma 5, so 5x5, so 5 width and 5 height, so 5 by 5 matrix. So if I run this, you can see uniformly distributed numbers between 0 to 1, but in two dimensional array. See, there are two square brackets are there. This tells us that it's a uniformly distributed matrix between 0 to 1. If you have learned probability before, you might have learned about uniformly distributed numbers as well. That happens to be between zeros to 1. So this is how you get it using rand function from random library from NumPy. I hope this is very much clear, guys. So basically, rand works around with uniform distributed numbers. I hope this is very much clear. Next, but there is one more function. So I will say np.random. Like just like we have rand, we have something called as rand n also. Now rand is used for uniformly distributed numbers, while rand n is used for standard distribution numbers. So I can pass rand n and I can say 2 comma something, 2 comma 5, or I can just say 2. Okay. As soon as I shift plus enter, you can see that it created a vector of, this time it is not uniformly distributed. This is a standard distribution, which is almost set around 0 only. But this is a standard distribution of randomly generated numbers. So every time you run this, it will keep on giving you numbers of standard distribution every time you run it, because ultimately we are working with random numbers in this case. So sometimes it gives you minus value, sometimes it gives you positive value. So it happens to be like that. So this time it gave me 1. But this is all your single dimensional array in this case, or a vector, because we passed only single number. Now same thing can be used with two numbers also. So I can say two numbers. I said 5 comma 5, so 5 by 5 matrix I want. So see, this is a standard distribution of numbers, and we got 2D array for 5 by 5 dimension of standard distributed numbers in this case. Every time you run this, every time you'll get a random numbers two-dimensional array in this case using rand n. I hope this is very much clear, guys. Very much important, guys. Okay. This is how you can use rand n. Now another function that we have in random is np.random, and I can say dot rand int I can say. Now this rand int is going to give us numbers, any random integer number between the range of I can say 1 to I can say 100. As soon as I run this, okay, it's rand int, and if I run this, you can see it gave me this 80. Between 1 to 100, of course, it will not go till 100, it will go till 99. If you want 100 also to be included, you will say 101. Okay, and then you will run this. So it will give you the numbers between 1 to 100. I hope this is very much clear. So this is rand int. It is going to give you a random integer between this lower and upper limit. So every time you run this code, it is going to give you some random number. I hope this is very much clear, guys. Similarly, if you want some set of numbers, you can pass a third argument. I said, I want some 10 random numbers between 1 to 100. Okay, and if I run this, you can see that it gave me an array. It created an array and it gave me an array of randomly generated numbers between 1 to 100. And it is going to give me an array. So every time I run this, the numbers values will change because it's a random, random library that we are using. Every time I run this, you can see this is how your random function works inside your NumPy array. So I hope this is very much clear, guys. So this is how you can use random numbers. So this is all about NumPy, guys. I hope you have liked this tutorial about NumPy. We have got into depth about NumPy arrays. We learned about all the things. So let's quickly go ahead and revise all the things once. So if I want to create a NumPy array, we used to create a list. And after that list, we used to import the NumPy as NP. So this was the alias name. Without writing NumPy.array, I was just saying NP.array. I created this array by passing this list into this array, and then I printed that array. So once an array is a 1D array, it is called as vector. If you want to create a matrix, or in this case 2D array, you can create lists of lists. So I can create a list of different lists like that, and I can pass that into my array function. And this array function will create a two-dimensional array, or in this case matrix, NumPy matrix or NumPy two-dimensional array. In this case, this is how we do it. So this was the traditional way of creating the arrays, guys. And without using the array function, you can directly use arrange function, which will directly smartly create the array depending upon the numbers and the dimension you want. For example, I would have said np.arrange and I passed only two numbers and it gave me the numbers array like this. Similarly, if you want to pass a third argument, you can do that and you can create steps. I hope this is very much clear. Arrange is very similar to using a range function, which comes from Python for loop. So half of the things are depending upon Python. So basically, for this course, you need Python basics. So you should know about Python also. Okay. Now coming up to NP zeros, so NumPy zeros. So if you want to create an array of zeros, you can just say np.zeros and just pass the number, and there you go. You will get the array of zeros. If you want to get this is a vector, by the way. If you pass single number, it will going to be a vector. In this case, vector or single dimensional array. And in the next one, if you pass two numbers, it is going to be that particular two-dimensional array. How to get the two-dimensional array? By seeing double square brackets in this case. It's telling us that it's a two-dimensional array or a matrix in this case. Okay. Next, the same thing what you did with zeros, you can also do it with ones. So exactly creating single dimensional array or vector in this case of ones, and creating multi-dimensional arrays or say 2D arrays or matrix in this case using ones. Then linspaces. Now the important thing that you should know is the difference between linspace and arrange function. In arrange function, we were writing third argument as the steps. So those many numbers were getting skipped. But in linspace, we give third argument as not steps, but as points. So points are the difference between that particular lower limit and upper limit. So I said 0 and 5, and between 0 and 5, give me all the numbers with 100-point difference. So dot after decimal point, 100 points difference I wanted. And it printed all the numbers between zeros and 5 with a 100-point difference. I hope this is very much clear, guys. So see, and the way it is printing doesn't mean it's a multi-dimensional array. It's still a vector. It's still a one-dimensional array by seeing this single square brackets. If it was double square brackets, then it would be a two-dimensional array or a matrix. But in this case, it's a single-dimensional array or vector. So this is how linspace works. Then next we will learn about the identity matrix. In identity matrix, we used .I. We passed some number, and that was your identity matrix. We got it. Of course, it's an identity matrix. It's a two-dimensional array. So we have two square brackets in this case. Then a very important function we learned about, which was random function. And in random function, we used random.rand, which is going to give us uniformly distribution between 0 and 1. If you have learned about that in probability, you might have know about the uniform distribution from 0 to 1. Okay, then we have standard distribution. When you use rand n, it gives you standard distribution number. When you use only rand, it gives you uniform distribution from 0 to 1. I hope this is very much clear. Now, depending upon the single number, if you pass single number in this, it is going to give you a vector. If you pass double number in this, it is going to give you a matrix in this case. I hope this is very much clear. Similar to that, rand n also, if you give pass one single number into that, it is going to give you a vector in this case. If you pass two numbers into it, it is going to give you a two-dimensional array or matrix in this case. Then the rand int was used to give us a random integer number, one single integer number between these two numbers. Okay. Similarly, if you want to print many numbers of random generated numbers, you can give us third arguments as how many numbers you want from it, from between this and this. This is very much clear. This is the whole tutorial of your NumPy. Whatever we have learned into this NumPy class, all of these things we will be mostly using in our future videos also. There are now more and more functions that you can go and explore by your own. But learning all these functions, you can understand it very well, and you can also, it will give you a kickstart for learning more and more functions in NumPy. You can now go and explore about more and more functions in NumPy, and you will understand it much more better. I hope you have understood this class very well. This lecture was dedicated on NumPy. We started from what is NumPy, and we learned about so many numbers into this NumPy. And for your references also, I am going to give the link for this notebook. I'll give the whole notebook link in the description, also a Google Drive link, so that you can refer to this notebook also, and you can understand how we can work around with NumPy as well. So I hope this is very much clear to you guys. Thank you for hanging around in this video, guys, and learning about NumPy with me. This is the basics of NumPy that I have told you now. So if you have any doubts into this, you can ask in the comment section below. I'm gonna clear all your doubts in the comment section. And thanks for watching again, guys. And before I go, don't forget to like, share, and subscribe to our channel, Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. Well, this is all for this video, guys. This is Ashang David signing off. I'll see you guys in the next one. Till then, happy learning.